Hi, I'm Shannon Seaver, and today we're going to be talking about exponential functions. And on our agenda for today is to define them, first of all, and graph them. We're actually going to also look at a couple application problems. So first of all, an exponential function is in the equation of the form y equals ab to the x, where b is always greater than 0. So, many cases, A represents the starting or initial value, and B represents the multiplier or the growth and decay factor, and you're going to hear me talk about that more in just a minute. Here we have x as the power, and that represents the time. So first, let's talk about exponential growth. Exponential growth happens when B is greater than 0, but it should also say when B is greater than or equal to 1. So let's look at a t-chart. We're going to set up some x values here, and then we're going to put them into our equation and see what our y values are and then graph them. So let's put in these x values into our equation here. So we'll have 3 times 2 to the negative 1, and that's the same thing as saying 3 over 2. And then if we put 0 in, that'll be 3 times 2 to the 0. Remember, anything to the 0 power is 1, so that'll be just 3. 3 times 2 to the 1 is going to be 6. 3 times 2 to the 2, that'll be 4 times 3 is 12. And then 3 times 2 to the third will end up being 24. So we have the points of negative 1, 3 halves, and 0, 3, 1, 6, 2, 12, and 3, 24. So let's look and see what that looks like on a graph. And here we have it already graphed for us. If you notice that this graph, as it's approaching 0 going in this direction, it never actually reaches 0, and so therefore the x-axis is called an asymptote. And so that is a key phrase that you need to write down in your notes, asymptote. It approaches it, it acts like a force field, however, and never ever reaches 0. And here if you look, you see it goes up quite quickly. So this is what an exponential growth function looks like. Okay, so let's do the same thing for an exponential decay. Now notice our b value here is between 0 and 1. So let's set up a t-chart here for the same things that we had before, negative 1, 0, 1, 2, and 3. And if we put these equations into our calculator, we'll have 2 times 0.75 to the negative 1, 2 times 0.75 to the 0, 2 times 0.75 to the 1, 2 times 0.75 to the 2, and then 2 times 0.75 to the 3. And I already have that as graphed as well. And if you look at this, we have a graph that's going down instead of up. And again, we have an asymptote of the x-axis here. So growth is going down from left to right. Decay is going down from left to right, and a growth one is going up from left to right. So just notice that the difference is what the value is. You'll see that this is some value in between 0 and 1. It's a fraction or a decimal. Okay, so another form of an exponential equation besides what we just learned, which was y equals a b to the x form, there is this one, y equals c times 1 minus r to the t, where c is our initial amount. That was the initial amount in a. R is our decay rate, and it's always expressed as a decimal. They'll give it to you in percent, say like 30%, but you're going to want to express that in decimal form, which is 0.30. T is in time, and if it's a decay, you're going to subtract 1 minus r, and that's what this is talking about here. If it's growth, you're going to add it to 1. So this is decay here, this is growth in this case right here. So you really need to read your problem to know which one you're going to use. So let's look at 3 examples here, and we're going to use that. I'm going to write it back up here again so that we remember. It's c times 1 plus or minus r to the t. Okay, so we have $24,000. That's our original amount, so I'm going to put that in for C. And it depreciates or decays by a rate of 10% a year, and our decay rate is 0.10. So let's put this into our equation. We have y equals 24,000 equals 1 minus 0.10 to the t power. And then if I'm going to simplify this, this will be 24,000. I'm sorry, this shouldn't have been an equals. This should be a multiply here. 0.90 to the t power. So that is what our equation looks like. Let's look at example 2. Here we're supposed to write an exponential growth and decay model for some stock, which was valued at 300. That's our original amount. The value increases, so this is a growth model, and our rate, if I put that in decimal form, is 0.09. So let's write this. Y equals 300 and 1 plus, because it's growth, 0.09 to the t power. So now that's going to be 300 times 1.09 to the t. Okay, so let's set this one up. We have a used car for $9,000. That's our original value. And the car depreciates 9% a year. So that's 0.09. And the value after 10 years, so that'll be 10. So let's set this up. We have y equals 9,000. We're taking a depreciation, so it'll be 1 minus 0.09 for 10 years. So 9,000 times 0.91 to the 10th power. And if we put that into our calculators, we're going to end up with $3,504.75. So our car will only be worth this much after 10 years. That is the end of this video, and if you have any questions, bring them to class tomorrow.